Hello everyone! In today's video, we're going to learn more about centripetal and centrifugal force using real-life examples as well as demonstration video for a clear understanding.
What is centripetal force? By definition, centripetal force is the net force that acts on an object that keeps it from moving around in a circular path. For equation for centripetal force would be Fc equals mv squared divided by r, where m is mass, tangential speed is v, and the radius is r. The units for centripetal force is in newtons, and to get a better understanding, the tangential speed is squared, so this means that twice the speed is needed for 4 times the force, and in other words, half the speed needs quarter force. There is an inverse relationship between radius and the centripetal force. So as an example, when the radius increases, the centripetal force decreases. And in other words, when radius decreases, the centripetal force increases.
So now I'll be talking about how centripetal force can be applied to real-life examples. First, I'm going to talk about the moon. Now, the moon revolves around the Earth in approximately a uniform circular motion. Now, this is possible because of the gravitational force on the moon, which provides the necessary centripetal acceleration to keep it in orbit. Second of all, I'll be talking about the washing machine. Now, when the washing machine is in use, the drum applies a force to the clothes, pushing them towards the center, which is an example of how centripetal force is used. Third of all, it's the merry-go-round. Now, merry-go-round exerts a centripetal force on the person riding it. Basically, the more we move away from the center of the circular motion, the more centripetal force will be applied to the person on it. Now, this just basically explains that there's a force that pulls the rider to the center of the circle. And fourth of all, we have the roller coaster. Now, when it is traveling through a loop, the object is moving towards inward, which is what we call the center of rotation. Now, basically, how centripetal force is used is that it keeps the roller coaster, which is the object, along a curved path.
Centrifugal force is an apparent outward force. Center fleeing might be a helpful term to memorize its definition. The equation for centrifugal force is F equals m times omega squared times r. M represents mass, omega represents angular velocity, and r represents the radius. It is important to note that centrifugal force is considered fictitious, which means it doesn't actually exist. The force that an object experiences moving along a curved path that pushes outward is actually a result of inertia that wants to continue in a straight line, resisting centripetal force acting toward the center.
So for our skit today, we are going to be demonstrating the concepts of centripetal force and centrifugal force, where me and Rachel will act out the examples.